Okay, so this is chapter 6, day 1, multiplying, dividing, and simplifying. So most of what we're going to be doing is simplifying, so we're going to start with that. So we're going to simplify rational expressions. And there's a lot of ways to think about this so you don't make goofy mistakes. And I'm going to try to point those out to you as much as I can. So when you simplify, the basic process in a nutshell is factor everything and cancel. That's the whole process, is you factor absolutely everything and then you cancel. All right, so I'm going to start with one of the most missed problems. As simple as it is, it's one of the most missed ones in all grades, in all math classes. It is this one. Yeah. So the mistake that people make is they go, 3x and a 3x, I can cancel those. You can't. And so a lot of what I'm going to be showing today is helping your brain think about it or see it a different way, so you don't even see those as the same thing. So how do we know they don't cancel? Pretty simple. A 3x is what we call a monomial. It means one term. One term has no pluses or minuses. X squared plus 3x is a binomial. When you cancel anything, it's all or nothing. So it's the whole binomial. So that's why you can't pull a piece off of it, because with that plus, these two are linked. You can't pull them apart. So if you can make your brain see this as a monomial and a binomial, it'll also make factoring a lot simpler, because when you factor a monomial, you prime factor into 3 times x. When you factor a binomial, you start by dividing out what you can and then see if it's a squared minus b squared. So out of those two, I can divide in x, and I'm left with x plus 3, which is very definitely not a squared minus b squared. Okay, so at the top, we still have a bunch of monomials. Now they're primes. Once you divide a number out, that factor becomes a monomial factor. And what's left is still a binomial. So after you've divided something out, now you've got a monomial and a monomial. I can divide out an x and an x. And you're left with a 3 on top and an x plus 3 on the bottom. And again, you cannot cancel those 3's. That's a monomial, one term. That's a binomial, 2 terms. So in your brain, you got to really see this like there's parentheses around it. Like that's an x plus 3 that comes all one piece. All right, so that's like the one that's the most prone to error. So let's go to one of the more difficult problems. So example 2. On the top, we're going to have 6x squared minus 30x minus 36 over 3x squared minus 3. Okay, in your algebra brain, you want to say, hey, that is a trinomial. It's got 3 terms. When we factor trinomials, we divide out, and then we do ABC factoring. This is different than the bottom, which is a binomial. And for binomials, you divide out what you can, and then do a squared minus b squared. So by naming the number of terms, it's also helping direct which type of factoring you're supposed to apply to it. So it's just kind of good all around. All right, so for the top one, I can take a 6 out of all 3 of those. That leaves me with x squared minus 5x minus 6. On the bottom, I can divide a 3 out, and that leaves me with x squared minus 1. We're going to do something with the 6 and the 3, but normally I recommend that you finish factoring the whole thing before you start canceling, because it just avoids a lot of goofy mistakes. So 6, though, is a monomial, so I'm going to prime factor it into 2 times 3. And then this trinomial factors into x minus 6 times x plus 1. On the bottom, I have a monomial 3. And this is definitely the difference of 2 squares, x plus 1, x minus 1. So once you've got the whole thing factored, now do your canceling. So 3 goes into 3, X plus 1 goes into X plus 1. Any monomials that are left just get multiplied together. We just have a 2 though, so it's just a 2. And then the X minus 6 stays in its factored form over X minus 1. And that is your answer. So factor everything and then cancel, and you have your answer. All right, we're going to do one more of these, and then we're going to move on. I want to do one with some quadnomials. So on the top, we have a cubed minus 2a squared plus 2a minus 4 all over a cubed minus 2a squared minus 3a plus 6. All right, so in your algebra brain, you want to not see these as 4 different terms. You want to see this as one big quadnomial and this as another really big quadnomial. The only way you can cancel quadnomials is if they match perfectly. These are close, but not exactly. So we can't just cancel those two and get a 1. But they are all one piece. Okay, so quadnomial, that would be factor by grouping. So we're going to take the first one and group the 2 terms. I can take an a squared out of those 2, and I get an a minus 2. Plus, I can take a 2 out of the second ones, and I get a minus 2. We're going to come back to that. On the bottom, for the first 2, I can take out an a squared, and I'm left with a minus 2. Now, out of the second 2, my a is negative, my number is positive. So I'm going to take out a negative 3 so I can switch the signs to a minus 2. Now, again, you're not done. It's really tempting to start like crossing stuff out, but we're not quite done. So on the top, you're going to divide the a minus 2 to the front, and then you're left with a squared plus 2. On the bottom, you're going to divide the a minus 2 to the front, and you're left with a squared minus 3. A squared plus 2, a squared minus 3 don't expand. Most of the time when you use factor by grouping, you're done. Very rare. I can't remember the last time I saw something where I actually expanded a factor by grouping. It's usually just done. So we're all factored. So what do they have in common? They both have an a minus 2 factor. And then what I'm left with is 2 completely different binomials. So we can't divide those, so we're done. It's a squared plus 2 over a squared minus 3. And again, in the beginning, you might want to put your parentheses around there just to reinforce to your brain cells that those are 2 different binomials. It's all or nothing. All right, any questions about that? Okay, let's go to multiplying, which is the next easiest thing to do. Multiplying. Okay, in order to multiply monomials, you need some rules. So let me show you an example of a monomial type of problem. You've got 6x squared y cubed all over 2x squared y squared times 10x cubed y to the 4th over 18y squared. Okay, over here on the right, we're going to list the rules as we use them, just in case you need a little review. Okay, so the first rule you need to know is when you're multiplying fractions, which I think most of you know this, but I'm just going to make sure. A over b times c over d. You just multiply the tops, multiply the bottoms. You end up with AC over BD. So when we multiply these together, we're going to push them together. The monomials of the numbers go to the front. So the 18 and the 10 are both going to go to the front. And since they are monomials, we're going to prime factor them. So I'm going to do both at the same time. So I have a 6, which is 2 times 3. And when I push the 10 up there, it's 2 times 5. So you can move them forward and factor them in the same step. Okay, on the bottom, I have a 2, which is prime. And then I'm going to move the 18 up front. And 18 is 2 times 9. So 2, 3, 3. So that's the first thing you do. Move all the numbers to the front and prime factor them. Now we got to do stuff with the x's and the y's. So here is your first exponent property. X to the n times x to the m. If the bases are the same, then keep the base, add the exponents, n plus m. So that's what we're going to do. We're going to multiply an x squared and an x cubed. Keep the base, add the exponent. 2 plus 3 is 5. Now the y's, keep the base, y, add the exponent. 4 plus 3 is 7. Now the bottom, I have an x squared with nothing else, so just recopy x squared. And then I have a y squared times a y squared. Keep the base, add the exponent. 2 plus 2 is 4. So that's your multiplying your exponents. Okay, what about dividing your exponents? If you have x to the n over x to the m, you combine them into a single x over 1, and you subtract the powers top minus bottom, n minus m. Okay, so looking at this, we've already got everything prime factored out. These are all monomials, so we can have at it for canceling. So 2n2, 2n2, 3n3. So that leaves me with a 5 on the top and a 3 on the bottom. And then now I'm going to use my multiplication rule, or division rule, excuse me. X to the 5th minus x squared is x to the 5 minus 2, which is x cubed. Top minus bottom. Now the y's, top minus bottom, 7 minus 4 is 3. And we are completely reduced and multiplied. All right, a couple other properties that you might run into. If you have x to a negative exponent means reciprocal. So it means you're going to go 1 over x, and then once you've moved it, it doesn't need the negative anymore, so it just becomes a positive power. The negative power does not mean the number is negative. It just means reciprocal. And the same thing goes if it's on the bottom. If it's 1 over x to the negative m and it's on the bottom, it means reciprocal. So the x to the m will move to the top and the m becomes positive once you've moved it. So those are a couple of properties I think you might find handy. Okay, so that's multiplying with all monomials. Any questions about monomials? Okay, let's get a little more wild and crazy. We're going to multiply with binomials and trinomials. Here we go. The binomial, 3x minus 27x cubed over trinomial, 3x squared minus 2x plus 1 times, the second one has a trinomial, 3x squared minus 4x plus 1 over a little monomial, 3x. Again, oh, it's so tempting to start crossing stuff out, but we can't because these two, that's a binomial, all or nothing. Underneath of it is a trinomial, all or nothing. In the second fraction, it's a trinomial, all or nothing. And then we've got a little monomial, which has to match another monomial. So that's why nothing cancels, because they're all trapped in their little polynomials. So now we're going to factor, factor, factor. So out of the binomial, I can take out a 3x, and I'm going to shortcut this a little bit. It becomes 1 minus 9x squared, which is a difference of 2 squares. So 1 plus 3x, 1 minus 3x. The trinomial factors into 3x minus 1 times x minus 1. All over. I'm going to push the monomial to the front, so the 3x goes to the front. And then the trinomial factors into 3x plus 1 times x minus 1. So you take as many steps as you need to completely factor it out. All right, and now we get to divide. So monomial 3 goes into monomial 3 one time. X goes into x one time. 1 plus 3x and 3x plus 1 are the same thing. So we can divide those out. We also have an x minus 1 factor on the top and the bottom. Okay, so what have we got then? We've got 1 minus 3x times 3x minus 1. Now, here's something that we don't bother with in Algebra 1, but as Algebra 2 students, you are expected to do it. The last part of factoring is to get the factors into standard form, if they are not already. And basically, in standard form, the x term is first, and the first term is positive. So the x term is first, and the first term is positive. So this one looks good. I got a 3x first, and it's positive. It's this one that's problematic. Not only does the 3x need to come first, it's got to change sign. So the way you change its sign is you just factor out a -1, and the negative just goes in front of the parentheses. And then now that the 3x is positive, put it first. The 1 is now negative, put it second. So now we're in a finished form. And again, this will make sense later as we start to work on other specific equation forms. Okay, just to reinforce that, this is just a little shorty example. Let's say you've got 4x minus 1 over 1 minus 4x. If you can tell it's the same factor, it's just off by a 1, then yes, definitely divide the negative out. That will give you 4x minus 1 on the bottom and 4x minus 1 on the top. Here we got to be a little careful. 4x minus 1 goes into 4x minus 1 one time. You will never get a 0 if you're dividing factors or canceling factors. The lowest thing you can get is a 1. So now we've got a 1 on top and a -1 on the bottom. And 1 divided by -1 is a -1. So the other thing we got to be, and you know this because we've talked about it, but just to remind you, if you have a negative monomial on the bottom, you've got to simplify it up. So positive divided by a negative is a negative, and the sign goes up. So negative monomials must be on top. And that's something I think you already know, but want to just remind you. All right, last thing, division. Okay, so I already know you know how to do division the regular way, flip the second one, multiply, right? You all know that. That's not the one they put on the SAT and the ACT. They put stacked fractions on. So I'm going to have you practice stacked fractions with the easy ones, which are the next two assignments are the easy ones. And then we'll get harder later, where you get stuff that you can't flip the second one and multiply. It won't work. So we're going to practice stacked while it's easy. And then we'll slowly get more challenging so that when you hit that problem, that looks, you know, something like this. That you're able to do it. You can't flip the guy and multiply. It doesn't work on that. That's what they put on those standardized tests, is that one every year. So we'll work our way up to that. We're going to start simple. They're really not that bad. Just have to get used to it. So Roman numeral 3 is dividing by stacked fractions. And again, I know you know how to do the flipping the second one and multiplying. I'm not worried about that. Okay, so dividing by stacked fractions. Number 1, factor everything. Factor everything, top, bottom, top, bottom. So factor everything. Okay, and then here's the step that gets rid of the bottom part. You're going to eliminate the bottom with its reciprocal. Eliminate the bottom with its reciprocal and multiply the top by the same numbers. So identical. So eliminate the bottom with its reciprocal and then multiply the top by the same exact numbers. And that's because you can multiply anything by a number over itself because what? 3 over 3 equals what? 1. Yeah, so you can multiply anything by a 1. That's always legal. And then, of course, at this point, you simplify, which is exactly what you will have already been practicing. Okay, I'm going to do 2 examples, but I'm going to put a line down the middle because I keep scooching the one too far over. This will help me stay lined up. Okay, example 1. We are going to do 4x minus 1 divided by 16x squared minus 1 over x plus 3. Now, you've heard me say this before, but the little division symbol is a tiny, tiny picture of a fraction. And so you have a fraction bar, and the dot on top is a number, and the dot on bottom is a number. So the first thing goes on the top, the second thing goes on the bottom. So I'm going to put 4x minus 1 over 1, because we're going to need the space. I'll show you in a second. All over, and then the other one goes on the bottom. 16x squared minus 1 over x plus 3. So that's the first thing we did was we set up the stacked fraction. Okay, second thing we're going to do, factor everything. So 4x minus 1 is a binomial, and it is not a squared minus b squared, so we're done, over 1. Now, 16x squared minus 1 is a squared minus b squared, so we're going to factor into 4x plus 1, 4x minus 1, and then underneath of it, x plus 3 is not a difference of 2 squares, so it's done. Now, what's going to really help your brain cells is if you make this middle bar heavy and dark, because you need to know where the top fraction is and the bottom fraction is. That can really mess you up. Okay, so we've factored everything. Now we're going to multiply the bottom by its reciprocal. So the x plus 3 goes on the top, and then 4x plus 1, 4x minus 1 goes on the bottom. And then we're going to multiply the top of the fraction by the exact same thing. So x plus 3 on the top, and then 4x plus 1, 4x minus 1 on the bottom. Now, this next step, I'm pretty sure you can just skip, but this is notes, and I want you to understand what happens to the bottom. So what happens to the bottom is anytime you multiply something by reciprocal, you get a 1. X plus 3 goes into x plus 3 one time. 4x plus 1 goes into 4x plus 1 one time. 4x minus 1 goes into 4x minus 1 one time. So in effect, the entire bottom of this fraction is now a 1 because we multiplied by the reciprocal. All right, on the top, you're going to immediately see some stuff you can cancel out. I can cancel out a 4x minus 1 on the top and the bottom, and what's left is done. So I've got x plus 3 over 4x plus 1. And again, I would not expect you to write this, but I want you to understand it's now over a big 1. And anything over a 1 is itself. So our answer is x plus 3 over 4x plus 1. So the entire bottom divides to 1, and then we can disregard it. Any questions about this so far? We're going to do one more example before we wrap this up. All right, we're going to do one last one, and then we're done. So this time I'll stack it in the first step. We're going to have 3 over 4x minus 8 all over x squared plus 3x over x squared plus x minus 6. All right, so we got it stacked. First step, factor everything. So 3 is a monomial. It's factored. That's as good as it gets. 4x minus 8 is a binomial. I can divide a 4 out and I get an x minus 2. And that's done because it's not a difference of 2 squares all over. On the bottom, I have a binomial. I can take an x out and I'm left with x plus 3 over. And then I have a trinomial, which factors into x plus 3 times x minus 2. And again, there's your middle bar. Now, if I had a bunch of monomials hanging out in the front, I would go ahead and prime factor the 4 because there might be stuff that cancels. As it is, though, I just have an x and a 4. There isn't anything else that could possibly cancel. So we're ready for the next step. Multiply by the reciprocal. Oh, you notice how you've got an x plus 3 over an x plus 3? You can cancel that ahead of time. So then I'm just multiplying by x minus 2 over an x. And they're going to multiply the top by the same thing, x minus 2 over an x. So just like before, everything on the bottom divides to 1. And all we have left is the top. And on the top, you can tell we have a binomial x minus 2 top and bottom. So that cancels. And we're left with 3 over 4x all over 1, because the bottom is 1. And then that gives you 3 over 4x. And again, I understand you'll probably skip from this step to this step to the end. That's perfectly fine. I just wanted you to make sure you track that one. Okay, that is everything. Are there any questions about division?